And we're live. So Kumar, you want to start with questions?
I just had that one question actually.
Okay.
How do you extract the pairwise results from the combined results? Or if it's possible?
Where you did this on Oracle?
Yes.
What directory?
My home and AHR.
So just for the sake of having a value for this recording, because you two are very advanced in terms of understanding each other very well, but Rad is better than me, but I'm the worst listener here, who has very little knowledge of all those details. Well, once there is a question that is clear to Jason, I would like actually that question to be repeated, so it is clear what the question is about, and then the answer should be followed with something. Imagine you're talking to a stupid student, me in this case, and I have no idea what the question was about, so you basically explain, right?
Okay, yeah. No, I don't know what the question is exactly yet either. At this point, I just logged into the server, and it's the Oracle, and then since Kumaran did it in his folder, I need to jump to super user permissions, and then now I can jump into Kumaran's home folder and look around as if I was him. And that's just for my purposes. Okay, so we're sequencing pipeline. And then, oh, Roddy, I just aliased O to LS.
It's not that. It's the AHR folder.
Oh, okay. Where is it? Oh, there it is. Okay. Okay, so did you modify the script, I'm assuming? Main scripts, run edgeR. Okay. So this is the classic run edgeR script, which Kumaran's probably modified some because there's really no easy way to make this script runnable from the command line without having to modify it, since there's too many options to change.
Really?
Yeah, I mean, I thought about automating it from the command line just so you could pass in flags and stuff, but the work required would just have been, well, you could do it, but there's just yeah, there's too many different things to worry about.
Yeah.
Okay, so let's see. This is R, first of all. This is the R language. And so there's two ways to run R. You can run, the simple way is to do pairwise comparison when you're only considering one group versus another, like a treatment versus control, or male versus female, etc. The more complicated way is the factorial way, when you're analyzing data that is chunked, especially, or split up into separate blocks. And for instance, if you have males and females, both with control and treatment in both groups. So now any given person is either male or female and was either given the treatment or the control. And so you can kind of blindly pretend like that's pairwise and do a pairwise comparison, males versus females, and just try to ignore the treatment versus control in that data set, or pick one or the other and half the number of data samples you have. But the best approach is to consider it all together in this factorial approach. So that's what Kumaran's done here. And I won't walk through the whole script because I did that in the previous video. Kumaran, was that reasonably helpful as far as?
Yes, it was.
Okay, good. And Roddy, if you watch the previous video, and it's confusing, then feel free to shoot me questions. But essentially, the area that's important is this one line here, where he's produces model matrix, which says that the gene expression is proportional to the type, which is just some variable defined in the key file that is passed in here. And then the treatment. What is type? Oh, stem cell versus non-stem cell?
Yeah.
Okay. And then treatment. And it's just the additive factors here, the main effects. So we're not looking at pairwise, or not pairwise, the cross terms, the interaction effects. And then we pass in the data here. Well, not actually. Then essentially some bookkeeping, some data munging, and then here's where we choose whether we actually run the pairwise or the GLM analysis. And so you run the GLM, and this is all just according to the documentation, so there's nothing there. Then, so at the very bottom here is where you actually pull out what you want. So I define these functions meta run because I'm tired of typing this whole thing every time. And the idea here is that meta run will test the coefficient in the model given by this number here, the coefficient number. And this is just saying, okay, give me the dimensions of the design matrix, which is the number of rows is the number of samples, and the number of columns is the number of coefficients in our model, generalized linear model. Then we only want the number of columns, so grab the second entry. That's what this guy is. And then take the very last one, which is this line, the second to last, which is this one, and the third to last, which is that one. So what that does is that for each gene, it runs the test of this coefficient and calculates the p-value that gene is different, that coefficient is different than 0. And what that means is that if it's different than 0, then that coefficient, let's say the treatment effect, will be, if it's different than 0, then that means that to describe the data, we have to use the treatment variable. So it's either upregulated or downregulated with the treatment on that gene.
The interpretation is that this gene is differentially expressed. So, for example, if the gene was differentially expressed in a regular t-test type of model, right? That's what would be captured by that non-zero coefficient in the generalized linear model.
Right. Yeah. It's
supposedly. Yeah.
Yeah, that's correct. And it's a lot easier to show if I let me probably run the analysis here. All my bindings. The problem with going to root is that all my key bindings are messed up. So new window. Yeah. Okay. So we'll start up R, and then we can go and source it. Source is how you pull in and tell R to actually start running the thing. And then here we can go look at the where we go, main scopes. Okay, so let me just show you what the design matrix looks like, because that makes it a lot easier. Oh, and let me explain this output here. So here at the bottom, I do meta run for the last coefficient, the second to last, and the third to last, and that automatically prints out some stuff and prints out some files too. So this is the file that first one printed out, and then it then prints out to screen here the number of downregulated genes, upregulated differentially expressed genes, and not up or downregulated genes. So that's just a kind of handy way to kind of judge how your analysis ran.
Which is the numerator and which one is the denominator?
Okay, yeah. So in the output of the file name, the first word treatment is the coefficient that you're testing, and then what comes next is the numerator of your tests.
Okay.
So this is TCDD over DMSO.
Okay.
And here, this is the type, the cell type, and stem cells versus. And sometimes it'll get this wrong, like it'll, because I think it does it alphabetically, or actually I'm not sure. I think it depends on your key file, and so you can actually. There's a way to change. Yeah, here it is. This line here. I changed the treatment column of the factors. Let me uncomment it. The treatment variable, the factors data frame. And if you don't know R, then don't worry about what that means. And then re-level it so that placebo is on the bottom, essentially. So then treatment would be on the top. But that wasn't necessary here. And then we go back to here. Then, okay, it tells you where it output there. Okay, so the way to, so getting back to your question, Kumran's question is, Jennifer did this analysis pairwise, and actually Kumran was originally going to do this pairwise. So even though there's 4 groups, there's stem cells and non-stem cells, and then each of those there's treatment or control, TCDD or DMSO or treatment and control. And I don't know exactly what Jennifer did, but I think this is a much more straightforward way to interpret the data, because now we can look at genes which were differentially expressed as a function of the treatment and those that were differentially expressed stem cells versus non-stem cells. And this is accounting for the other factors that we're not looking at here. So when we do this treatment analysis, we are accounting for the fact that we have 2 different groups, the stem cells and non-stem cells, in a very natural kind of way. So it increases your statistical power because you're using all your samples at once. It's just the right thing to do, really, statistically.
But I heard Jennifer saying the customer wanted only pairwise and without regards to the other factors, something like that.
So yeah, so in that case, what I would do is I would go ahead and run the factorial analysis, and then if they, for some reason, wanted to disregard half their data, then they could do that. And I can show you why that's bad. I'm trying to think if I can draw a picture here. Yeah, I can do a little ASCII art here. So tab view. So imagine this is sample 1, and this is actually this is the gene expression. This is 100, and this is 0 down here. And then for sample 1, this is really hard without my key bindings. Sample 1.
Your stream actually froze for me. I don't.
Oh, it froze?
Yeah.
Oh, is it back?
It's okay with me.
Oh, really? Okay. I don't see any changes.
Oh, well. It wasn't going to be a very good example. Well, should I continue? Is anyone interested in seeing this?
Yeah.
Okay.
Yeah.
So sample 1's there. Sample 2, sample 3. Or okay, let's actually change this to this is TCDD and stem cell. This is TCDD non-stem cell. This is DMSO stem cell, and this is DMSO non-stem cell. And now consider that we have these groups here. Yeah. And let's see. And then TCD non-stem cells. Whoa. Here. And then TMSO. Okay. So there's 3 samples there. Come on, is it coming through at all? Still nothing?
Not really, actually.
Okay.
But I see that, so the recording is going on, right?
Yeah, it should be. Yeah, I don't know why it's not going for Qumran. Qumran, if you want to see, you can SSH in sudo -I and then tmux attach, and you should see.
Okay.
Yeah. Okay, so in this case, stem cell for this gene, stem cells have higher expression, right? So when we go from non-stem to stem cells and non-stem to stem cells, you can see the expression increase in both of those cases, right? Does that make sense?
Mm-hmm.
But if you consider this naively and you just consider all your TCDD, or sorry, your stem cells together, this group and this group, then the average is somewhere in between the two here, but our variance is very large. And similarly for non-stem cells, the average would be somewhere here, and so it would be lower than the average of the stem cells, but the variance is so much larger that we probably wouldn't call a significant p-value. But given that we are looking at these independently now, we can say, oh, you know, this variance is very tight, this variance is very tight, and same with this and this. And so we can see this clear increase from non-stem to stem cells, regardless of DMSO or TCD. And we actually look at the variance in each case rather than trying to lump it all in the same case. So that's the primary advantage to the, or one of the primary advantages to the generalized linear model. Does that make sense?
This is a very good example. However, let's keep in mind that when you do multiple testing, you basically what you claim, Jason, and that's generally true, that the generalized linear model factorial model will produce more differentially expressed genes, right? Am I correct?
Mm-hmm.
So if you produce more differentially expressed genes, then the question becomes what happens with the step that does the false discovery rate correction. So in a way, it is, yes, beneficial because of this clear example which shows how the variance is handled properly with the factorial model, but at the same time, you will be facing false discovery rate correction anyway. So there is no clear, I don't believe anybody really knows exactly when one of these two approaches, the simplest t-test and the more general one, is the better choice.
Yeah, I mean, they're both models,
Yeah.
and so they're both wrong. The question is, you know, if your data actually does kind of look like this, then the GLM's going to be superior. It's just, you know,
You
have
don't
much
have
more
multiple testing problem here.
Well, but the multiple testing is actually the exact same.
Yeah, I know.
because you have the same number of genes, and so you apply the same Benjamin-Hochberg or.
But the naive approach will not even put certain genes into the perspective for multiple testing because they won't be called.
Yeah, that's true. I mean, you could just ignore more genes.
So in a way, multiple testing is easier when you ignore more genes. The correction. Anyway, the example was very good. So the example, I really like what Jason did. Those things are basically the expression levels, the way he plotted them. It's very nice. Thank you, Jason.
And actually, let me show you this quick example. So okay. I moved this one up here. And so this is showing that the gene is increased expression in stem cells under TCDD, but it's actually decreased in expression under DMSO conditions for stem cells. And so this you would only see with the GLM if you put in the interaction term. Mm-hmm. Because here you won't see it with just an additive term. And so going back to the R script, then the way to do the interaction term here, it's actually quite amazing how simple it is. You just actually, all you would do here is just change this plus to a times, and that'll do both the additive terms and the interaction term. And so now if you reran this, then these meta runs here, this final term now would be the interaction term, and this one would be the treatment, and this would be the, oh, and I can show you that here. So if we look at our design matrix, what do we call it? Yeah, design. Oh, cool, it fits in one screen. Okay, so this is a design matrix. So we have these, what, I don't know how many samples, 15 or something?
16.
16, wow, I guessed close. And you can see the intercept here, which is basically just all of these samples for all the genes have some background amount of expression. So that's what this coefficient would be here. And so we actually, here we accidentally ran the test against the intercept coefficient, which we didn't need to run because it's obviously going to be non-zero. And so we get all of these differentially expressed tests, are non-zero or near zero p-value. I don't know why it's negative, but anyway, it might be because the link functions log link. Yeah, it's probably something like that. And then you can see this stem cell coefficient here, is only 1 for the stem cells, and then the treatment variable is only 1 for the well, you can't see it, but and so Kumaran put that information in the key file, and then the model then uses this to learn the values of the coefficients that give the best fit for this overall model, and then so we're testing for these coefficients if they're non-zero, and oh, actually I can just yeah, let me do this real quick. And then if we look at this design matrix here, yeah, okay. We do this, and then look at design. Now we can see that because we made this a times, it now introduced this interaction term, which is only 1 when both it's a stem cell and under TCD. Mm-hmm. And so it adds a little extra complexity to the model, and more parameters to fit, right? So we have another parameter over here. And so by doing this more complicated model, it can actually reduce the performance of these guys here. It can improve as well, because there's more parameters. So you just have to kind of try both, and that's why it doesn't really make sense to make it runnable from the command line, because you really just have to play around with these kind of things. Any more questions?
Oh, I'm waiting for Kumaran because it's his show, basically.
Okay. Kumaran, are you there?
Yeah,
Okay.
I'm there, but I'm looking at a black screen, so I don't know what to say.
Oh, okay. So you didn't get Tmux working?
No, I was looking at the broadcast for some time, so I got those parts. Yeah,
Oh, okay.
now I got it back actually. It is intermittent.
Okay. But yeah, you can watch the broadcast later.
But can you modify the script to give an example of how to do the pairwise
Sure, I
model?
can do that. So let me undo this effect here. So pairwise, there's a few things to change. And I tried to document these a little bit, but I don't know how well I did. Okay, so right here we have factors being a data frame because we're pulling in multiple columns here. Yeah, multiple columns. So that's the first thing that we want to do is change that. Well, first thing, oops. So my bindings are not set up right. Okay. Okay, so this just requires counts, which we have right there, and then groups, which groups is going to be this guy. So that's unfortunate. We don't need a design matrix anymore, and we are going to do treatments. Okay. And so now we're calculating normalization factors, estimating common dispersion, doing tagwise dispersion. And then I believe there's one more down here. There's pairwise tests here. So here we factor that out and put it back there. Yeah, I think that's all. I think we would only need a test for one coefficient, the very last one. Yeah, we'll see if that works. Yeah, let's just try running it and see what happens. Oh, okay, another feature, and it's not a very well-named, my naming is not very good here. The script kind of organically evolved. So, as you can see here in the output, the outputs, here, analysis folder, AHR list, which is the name of your experiment file, and then edgeR 2x2, which this is a string that we can control to output multiple analyses. So this would be a good time to change that, which I called it the ename for experiment name. Not a great. So this would be like pairwise or pair treatment or something like that. Okay. So now we can go ahead and try running this. Oh, here we go. Okay. Source. Roddy, are you learning much? This is probably pretty overwhelming, considering it's an R and doing generalized linear models and all this stuff. This is the hardest part of the whole analysis, so don't feel overwhelmed.
My mic isn't working, so.
Oh, no, I can hear you now.
Oh, you can?
Yeah.
Oh, okay. Yeah, it's pretty overwhelming. I feel like I'm drinking from a fire hose.
Yeah. Let's see. So let's go and look at type stem treatment. I don't know why it pulled that out. Oh, I think that's residual. So just the naming of the file is bad here, because if you look here at the where it saved the output of the analysis, it named it type stem treatment, which makes it look like it's doing both somehow in the interaction term. But I think that is. How do I name that file? Oh, it's right here. Paste column. Yeah, okay, so it's actually grabbing the design matrix, which was something from our last run. So for doing a pairwise comparison, you would probably want to run something like a meta pair run. I mean, all that it is just the file name, so it's not really that important. But, so let's go look at it. New window. So what was that? Analysis, AHR list. And now you can see we have two folders. EdgeR 2x. Kumran, did you log in so you can see this?
Yes, I did.
Okay, good. Are you in my TMUX session?
Oh, no.
Oh, but you can see that.
I don't know. Yeah, I can see.
Okay, so you should try the TMUX thing though. It's really cool. Because then you can take over too. But anyway, so then now you can see that we have two folders. This one was the factorial analysis, EdgeR 2x2. And in here, there's several things. I think I described some of these on the last video. And then now we have the EdgeR pair treatments. And these actually, yeah, I guess those are still the same. Yeah, because Y is, yes, that would be interesting to look at. It copies the EdgeR script. So that's very helpful for reproducible analysis because you'll come back to this file and be like, oh, look at these differential expression analysis. And you'll wonder, was this done when I filtered out those genes or used this subset of genes? And now you can just go and look at the actual script that produced these outputs and just grab it right here.
We should do that for the whole pipeline.
Yeah, that's actually, you could literally just tar the whole pipeline up and just, yeah, save it. Because it's only probably just a few 100 kilobytes or something, and as compared to the BAM files or whatever, that's not a bad idea.
That's a good idea, yeah.
And then cat summary is actually just this output again, just so you can quickly get at the number of differentially expressed genes for each one. Wait, why did I go in the? I meant to go in the EdgeR pairwise. Okay. Yeah, cat summary. Okay, so there are 86 up and 53 down, and if we look at if they're comma. So commas T separator, I think it is. Oops, forgot to pipe it. Yes. So here you can see these are the genes, gene names, fold change, log fold change.
Yeah.
Log expression counts per million. P-value, false discovery rate, and then these are the average normalized expressions of this group and that group. I actually add these in. That's part of the script magic.
But normalized, do we know which normalization?
Yes, because I did it right here.
Okay.
So where is that?
Because that's an important part of the pipeline, if we use it or if we don't use it.
Yeah, so this is, I wrote this, get normalized counts for each group for outputting the summary spreadsheet. And so I apply the multiplication function to the counts, and I take the library size. Oh yeah, so I actually I forgot I did all this stuff. Okay, so that's the it's a rescaled. Oh, okay. I thought, yeah, okay. So it's not actually the upper quartile. It's using EdgeR's normalization factors itself, which by default they use the trimmed mean m values.
That was the latest thing. So
Yeah.
that's one of the things that we need to be very cautious about, because obviously different versions of the script use different sometimes normalizations.
No, our script's been consistent. I've never changed the normalization. Roger, I think, has played around with it, but so I guess you could be right. If Jennifer's using Roger's script, then who knows what she's using.
Yeah, that's precisely what I'm saying, because at this moment we're facing at a minimum 2 different EdgeR scripts, which probably will include different normalizations. So in a sense, what happens here, and that's how I view it, it is fine if somebody is versed with the script to change those things, but there are several things that need to be well documented for people who are just entering the mess. So first thing is to probably is a good idea, and you correct me if that sounds crazy, is to have 2 generic scripts that are possible to come up with from this EdgeR script that we're looking at right now. One of them is generically tuned up to the pairwise comparisons. The other one is tuned up generically to 2x2 factorial model with the interaction term. So instead of the person trying to figure out which lines to change within the code, they will have those 2 generic scripts, and they can examine them on their own time to see what the difference is in the commented out and commented in lines are. So basically a person can, in addition to this video, they can actually have their own examination of how different the extreme cases are in terms of the coding lines. What do you think about this idea?
So I think that's a good idea. The danger there is then you have code duplication.
Yeah, that's why I'm asking how that will be handled.
And so what I've done in the past, and what you're supposed to do, as a software engineer, is to factor out the common code into, a third file for common utilities. So what I mean by that, so this function here is completely common. No changes need to be made pairwise. And so this could just be, literally snipped out here and put into a library file, or just a utils.r, and then we could source, utils.r up here, and each script could do that. And same with this run analysis. I think all this could be put into the utils function, and so then it would actually make the script much smaller and tighter, easier to look at it in one go. It splits it up into multiple files, but that's okay. Yeah, I think that's a reasonable thing to do. And one other thing is, so this analysis that I just ran, the pairwise, naively combines the 2 types of stem cells, or the stem cells and non-stem cells together. Now, if you wanted to do the other type of shooting yourself in the foot, which is to ignore half the data, then that would be, you would essentially do that, you would need a factor or basically filter your data. So here counts, you would take, let's see, that's genes. So it'd be something like, you know, filter out the samples that you don't want here. And then, oops. And then you'd also need to filter it out in your key file. So you do like key, you know, filter the same samples here. And so once you did that, then you would ignore half your data, whatever half you didn't want to ignore or get. Does that make sense?
Well, it makes sense to me, but the question is, how can we force it to make sense to somewhat person who somewhat does not know all the intricacy of the code and statistics combined. So let's see what Kumaran's opinion is about this.
We could do the library thing, or we could separate the script into functions, maybe, and have a config file. Maybe put the type of analysis there, the columns that he's interested in, things like that.
I wouldn't bother with the config. I would just keep it real simple. Split the files into run pair edgeR and run factor edgeR. You know, just and then explicitly by what they run, it'll do the two analyses.
So once this is done, I propose to use me as a guinea pig and give me some instructions how to get on the machine and open those two files so I can look at them and see if I understand what's going on.
Okay, we can do that.
Yeah, and then I probably will collect some questions for you guys, and we can probably discuss how to make those the answers to those questions clear and how we can improve the overall accessibility of the code to people who will be trained eventually on that.
Mm-hmm. Yeah, I need to get rid of a few of these lines, like this stuff.
A little cleaning will help, but ultimately I can be the guinea pig because I haven't used the code at all. I do have some, basic programming knowledge, so I can try to figure out what's going on with this code after this meeting today, and then I can tell you what is not clear to me in terms of what the code does here and there, and then you can tell me, okay, well, let's make it clearer.
Yeah, unfortunately, R is not the clearest programming language. No, I'm definitely biased, but it's pretty clunky sometimes. So don't feel bad if it doesn't make sense.
That's why we're trying to put it as a backend running to the web interface. So
exactly. Yes.
People don't have to worry about this, and in some sense, we're running towards a selection of generic codes that will be used most of the time. For example, to me, there will be two major groups of people. One group, like customers, as Kumaran says. One type of customers would only be interested in pairwise comparisons. Simplistic stuff, they wouldn't care about factorial design or factorial analysis. The others will say, oh, we don't care, just do the state of the art, which means full factorial design.
Mm-hmm.
So once we know what the preference of the customer is, basically, the rest should be hidden from the customer how it is executed. So the customer can select something on the web page, and the rest should be invisible to them. Only the results should come out. You see what I mean?
Mm-hmm. Yeah, definitely.
And maybe, which is also important, we do have, we must have some options for normalization. Because some people like to do certain type of normalization, some people don't like those and they prefer different. So at least a couple or three options for normalization should be out there.
Okay.
And that should be, of course, reflected in the structure of the two generic HR code versions that will be run accordingly. How does that sound? As a
Yeah, that doesn't sound hard to me, but it's Qumran that's the important part.
Yeah, that's why I'm tossing that question to both of you to think about it. It's not something that we have to decide right now on the fly, but I'm just throwing some ideas at you, and that's what I believe will be the structure of our customers. They will have absolutely no desire to dig into the details of the HR code. They will have either simplistic understanding of pairwise comparison plus FDR correction, or they will say just do whatever is the best, and whatever is the best according to the current literature is the factorial design generalized linear model. So after that selection is made by a customer, then the rest should be pretty much automatic, plus the normalization procedure. But again, this is my opinion. So I'm not trying to decide about this right now because I am totally unaware of the details and what kind of consequences of for the code and maintenance of the code this proposition will have. So that's why I'm asking you guys to think about if what I'm proposing makes sense in terms of keeping the code accessible, no code duplication, and all those issues, and how we can reach some kind of reasonable compromise.
So my original idea for the differential expression web script was to just support the pairwise differential expression because it becomes trickier to do the factorial comparison, because then do you want the only additive terms or interaction terms or a mixture of the two, and how do you specify those on the web interface, and you have to put those into your R code, and it quickly escalates complexity quickly. Whereas if this is proof of principle and trying to get future funding, then I feel like much better is to start with the differential pairwise.
Okay, that for an immediate goal, that's the correct decision. So let's focus on the pairwise in terms of the web page design. Correct, Kumran?
Yep, sure.
And then in terms of actual doing work, which is the serious business, and that serious business is coming in terms of data coming from Johanna and other people, then factorial design should be there available, which it is in a sense with this code, but it has to be clear to people who's gonna go there and modify exactly how that modification should be performed, or we'll be facing like a fire alarm situation anytime somebody. Think about Jennifer, right? When I say somebody. Somebody tries to run the analysis, they go to this code and they scream, "Oh, Jason, help, I don't know what to do, come and modify the code for me." You see what I'm saying?
Yeah.
So we don't want this type of alarms to start going off often, because that means absolute waste of time. I'd rather have you guys think about how to prepare a product that is reasonably accessible, even by Jennifer, which might be a tall order, but anyway, this is how we need to think about the problem. Because as you can see at the moment, Jennifer says, "Oh, I don't want to touch my code that I got from Roger because basically she says I don't want to learn anything new." All right?
Yeah.
So we cannot solve this problem right now. That's definitely not an easy thing because of the complexity of the modifications you have to do from, again, I'm talking from Jennifer's perspective. If she was here on the call, she would be confused totally what modification she needs to do. So that's why my proposition came to have two different codes.
Yeah, I think that's reasonable. I actually need to go soon, so is there any wrap-up things?
Well, that's about it for now. I guess Kumaran can try to handle the simplistic version of pairwise comparison, starting from this code, to create a separate version of that code that he can try to implement with a web page.
Okay.
And the rest, please let me know when the new version of that simple version of the code is available. Use me as a guinea pig. Send me a notification how to get into the machine and how to look at the two versions of the code, and see if I can collect any comments and questions through that.
Okay.
And that's good for now. I hope that was helpful for Kumaran especially, because that was the main purpose of the recording tonight.